This is the notes for the physical properties, metric system, and some units. Be sure to answer these questions before you begin and continue along. Alright, so let's look at some ideas of physical properties. These can be observed or measured without changing what the chemical or compound is. Sometimes they're seen through physical changes, things like evaporation, condensation, melting, freezing, sublimation, deposition. Those are all types of phase changes. You also might notice in the idea of the different types, we have qualitative. Qualitative use essentially adjectives to describe stuff. Quantitative use numbers, not hashtags. They're not popular on Twitter. They're just numbers. So things like melting point, boiling point, those of course would be degrees Celsius. Density, something like grams per milliliter. Solubility would be grams per 100 grams of, let's say, water is often the solvent. Electrical conductivity, thermal conductivity, those are numbers we won't be investigating, but are quantitative physical properties. Qualitative ideas, physical state, color, odor, these types of things that we use to kind of describe different types of compounds are found with the idea of physical properties. Now when it comes to the metric system, this isn't new for you. You probably moved the decimal back in the day. We're going to be using a different method, a method of math that correlates to a majority of the math we do in chemistry, usually called what's called dimensional analysis, or sometimes called the factor label method. I don't really like that term. However, we do need to know the differences between these, and this will be given to you, but you need to be able to convert it at times to different things. This is used also in physics and other sciences. So get used to knowing which one of these prefixes is larger than others. Again, you do have this to reference back to on any kind of test or quiz, but your ability to use this is often what we'll be using in chemistry. It's less memorization at this point and more utilization of the tools provided. Now when it comes to units, there always is a unit after a number. So, for something like I took the mass of this iPad, that's 1,115 grams as the idea for mass. Length, I don't know, it's about 23 centimeters wide. The temperature, it's probably a nice 19 degrees Celsius. But these are all things that would be measured, usually of objects. So you'll be used to these in the idea that we'll be measuring these in labs and other activities. However, derived units we usually calculate. So something like grams per centimeter cubed or grams per milliliter. Molar mass we'll actually read and calculate off our periodic table. That's grams per mole. Area would be something like centimeters squared. Volume can be centimeters cubed, can be milliliters, could be liters. Energy could be things like joules and kilojoules. Those would be calculated and actually renamed from a different type of unit. So sometimes in chemistry or science, we will take a unit and it's so complex in all the units that are there, we go, that looks a little too complicated. Let's call those 4 units together doing math something else, like a joule, for example. Also, another type of temperature that you might not be used to is Kelvin. That's what's used in all of our mathematics when we calculate things. We measure in Celsius, we calculate quite often in Kelvin. Sometimes it doesn't matter, it depends on the calculation. But remember, you can use your prefixes to change any of those from meters to millimeters, grams to kilograms, and so on. So you'll get a lot of practice in using the dimensional analysis with something you're familiar with and with things throughout the year that you're not familiar with. So make sure that you can do these things and come in with any of your questions.